Understanding ASCE 7, Chapter 13, Seismic Drift Limits for Glass Components. Welcome to Building Knowledge 101. In this video, we explore the ASCE 7, Chapter 13 calculation for seismic drift limits for glass components and address the relative seismic displacement that cause glass fallout from a current wall, storefront, or partition. Next, you have your ASCE 7, Chapter 13 equations. So delta fallout is the drift that causes the glass to fall out from a current wall system and is determined either through ALMA 501.6 testing or by engineering analysis. To make sure that delta fallout is complied with, you can use this following equation. So your delta fallout must be less than 1.25 times your importance factor, which would range from 1 to 1.5 times your relative seismic displacement. And all glass in a current wall or storefront system will need to meet that relative displacement requirement. However, if there's enough clearance between the glass and the framing components so that you don't have physical contact between the glass or frame at design drift, then glass doesn't need to comply with that equation. So you can use the declare equation below to determine if your system can allow the glass to move around without coming into contact with the frame. So you're covered if you meet this declare greater than 1.25 times your design displacement. And the parameters for declare is your height of your glass panel, the width of the rectangular glass panel, the clearance is on the side of the glass in the frame, and then the clearance is on the top of the glass in the frame. So delta fallout is impacted by multiple factors. So you have your product design, the amount of clearance between the glass and the frame. So that would be your glazing pocket dimension, as well as your glass sizes, what type of glass you're using. Is it a capture system versus SSG system? Is it tape glaze versus silicone? All that goes into determining your glass fallout. And so these get into the limitations of the ASCE 7, Chapter 13 equations. As you get to some of these SSG systems, it can be very difficult to determine what inputs are you using into that equation. So always try to rely on testing instead of doing the equation when you can. So taking a look at the framing section, there are two main intersections between the glass and the frames. And these are where going to be your inputs into that ASCE 7 Chapter 13 equation. So first you have your glass bite, which is the amount of overlap between the frame and the gaskets and the glass panels. And then you have your glass pocket, which is the cavity in the frame between the glass that surrounds the glass. Next, you have your, in the SSG's mullion, though, you don't have a glass pocket. So this is where you run into difficulties with that equation. So now, where does your contact between the glass and the frame occur? In this case, it doesn't occur. So how do you put that in the calculation? That can be a confusing question, which is why we always like to rely on the testing rather than the calculation. Just a quick recap. So the more clearance we have in the system, the higher your glass fallout drift will be. And then, but the larger your glass, the taller it is, the lower your glass fallout drift will be. So your glass size has a really big impact on your fallout drift. So if you choose a product that isn't able to meet the drift you need, you may have to reduce your glass size. And that will lead to, increased mullions, more glazing, and just added cost to your project.
That's all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.